Started here now. So I'd just like to welcome Steph Piper, who's going to be presenting how 3D printing can assist small business. Okay, Steph. Go ahead.
Okay, welcome everyone. So my name's Steph. My day job is I worked out at the local university here at USQ, and I run the library makerspace down there. So it's of course shut up at the moment, but I'm working from home, and it's a space where students can go along and use the 3D printers to have a go at making some stuff. They get to learn how to use the machines, use the electronics bench, all that kind of stuff. Yeah, but before we get started too much further, I'd like to hear from you guys. If there's something that you'd like to learn in particular today about 3D printing and how it works or how you could potentially use it, if you've got an idea in mind, I'd love to hear about that now so that I can make sure that I cover it in the session anyway. Do you have anything in particular, Paul?
It's more of a personal thing. It's not necessarily business-based. I've just sort of been thinking, I've got a part in my car that I think I can't purchase commercially. I'm thinking maybe I can print that one day, but the problem is it's a fairly big hollow, like a container, and I think they have to be made in two parts. Otherwise, it would have a lot of that support structure in the middle of it. Is it? I'd be interested to know with 3D printing, is it fairly common when doing container or fairly hollow, lots of hollow things that you create in two parts and join them? That's relative to this or not, I'm not sure.
Yeah, depending on how big it is, I suppose, and whether you can easily make a 3D model that fits in that space. And I'll also talk a bit about the types of materials as well that are available and how much heat stress they can realistically experience. Usually stuff for cars is good for interior, not as much for the exterior or internal.
It is interior.
Yeah. As long as you don't leave it out on a hot day, you should be all right. But yeah, cool. I'll keep that in mind when we start getting through the content. How about you, Irene?
I got interested in 3D printing when I went to a workshop about 18 months ago, 2 years ago, from the guy who used to be the head of innovation at Disney. And I've been a big Disney fan follower, so I go around to whatever I can if it's Disney. And he talked about 3D printing. He was doing a lecture at, he didn't name who, but in the US, one of the giant hardware chain stores. And they were asking him to help them work out what they needed to think about strategically for their business for the next, they were going kind of 50 years. And he said, well, basically you won't be here in 50 years because 3D printers are just going to be the thing, and people will have them in their home. And if they want a tool, a hammer or a nail or a, hardware product, they'll just make it. They'll just type it in and out it'll come. And so you should be thinking much more creatively about where you want your business to be. So because of that, I did a bit of research around. Over the few years, I've been just Googling, where's 3D printing up to? And it is going that way with mass-produced products. And, hopefully you're going to talk a bit about that. But I'm curious always about whether it's got any benefit to the average business or whether you've got to kind of be a conglomerate to make it worthwhile. I'm curious as how it works because I see them printing meat and I think, well, but, how does that work? I'd love to see it in operation, but it's something that I talk about on my blogs about in terms of people thinking beyond what we know, and we hear about it, but we don't know really if it's that applicable to small business. So now I'm curious about that.
Excellent. That Disney talk sounds like it would have been amazing to see.
It was amazing. It's best 2 hours I've spent in a year.
Yeah. Excellent. Let me fire up the presentation and we will get started. Excellent. So today anyway, as part of the plan, hopefully you guys can see that all right. Can you see that okay?
I see. Yeah, yep.
Yeah, you got it? Excellent. Cool. Yeah, so today I've got a whole bunch of different samples to show you of example projects that I've been doing and lots of different ideas of sort of where you can be going. But anyway, the crux of the presentation today is I'll be talking a bit about some of the projects that I've done to start us off, give you a bit of a taster of what's possible. Then we'll go on to like pretty much the whole 3D printing process and what it tends to look like step by step, so that if you end up getting a machine in your house or with your business, you sort of know exactly what to do and how the workflow should operate, all the sort of hidden costs and where they lie, looking at all the different software, material choices. I'll have some recommendations for what machine as well to purchase depending on your budget at the end there too. Yeah, cool. So I've always been a huge fan of 3D printing. I got started with 3D printing back in 2011 when it was cool to go and buy like an open source 3D printer kit and put it together yourself. And with that experience, I was able to get into a PhD program at QUT looking at 3D printable biodegradable scaffolds implantation. And so I worked in medicine for a little bit on projects like this. Like the idea behind this one anyway was that if someone had breast cancer, you could 3D print one of these, and during a mastectomy or a lumpectomy to remove that cancer, you could implant one of these biodegradable scaffolds, and it would biodegrade over 2 years to form connective and fat tissue in the patient. So it'd be a more lifetime solution where they could go and get a mammogram, check the cancer recurrence, and it wouldn't burst on you in 10 years like silicone implants can. So I think like I've got a bit of an inside view on what the medical side of things is looking like right now. And honestly, a lot of the implant style stuff like this, I think we have a long way to go. So while this project was pretty engaging and interesting to work with, I feel like potentially stem cells and all that kind of stuff in tandem with 3D printing is probably where we're going to be going outside of the plastic surgery realm. Plastic surgery with 3D printed titanium, all that kind of stuff for like bone reconstruction, skull reconstruction is fantastic at the moment, and they're already using it in practice. But since doing this project, I've been doing quite a few other different medical sort of themed projects as well for the local community. There's this one here that I have been doing with the Toowoomba base hospital. And this one has, like, the idea behind this is that it's a cast for broken bones. So to make this one, what I did was I 3D scanned my own arm and I designed this one to fit me exactly. And the idea behind it is that it has a whole bunch of holes through it, so that if you've ever broken your arm or you know someone that has, they usually get a huge heavy plaster cast put on, which is like getting all sweaty and itchy and nasty on the inside, and it's not a good time for that patient. And if you can have something like this that has a whole bunch of holes through it, you can go for a shower, go for a swim, get a really cool tan, very important, all those great things along the way when you're making one of these for a patient. So since doing this project anyway, of course, I ended up making like a few that some of the heads of the hospital could wear to a big conference to show off. And it was very well received there. But of course, unless you have a real startup company to drive the action behind like an idea or a concept like this, you're not going to see it in actual practice until that happens and until the hospital can sort of buy it from somewhere. So what I ended up doing with this project, rather than waste all the work that I'd done on it, I have now made it an open source project up on instructables.com with an associated video as well, so that anyone now can make exactly this product for themselves if they want to, if they have say a repetitive strain, wrist injury or something like that, to actually, use it themselves or potentially, build on the idea. So I see there's a comment there. Can we make Steph bigger? Yes, we can. Let's try and see if I can do that properly. Can you see the images that I've got here? If I'm screen sharing? No.
Yeah, we can see the images. It's just on the recording. What you're showing on your video is just going to be tiny in the corner.
Yes.
And the screen is big. So just if you're going to show something on your video, maybe just stop screen sharing for the time being, just so the video will capture it big. Yeah.
Okay, good idea. I'll stop screen sharing then for the moment then, and just so you can see big me. Cool. Okay, so...
Sorry, Steph, can I just interrupt for a second? Joy, can I control that at all, or is that...
No, and sorry, that message was meant to be just for you. Oops.
Oh, yeah, I thought so. All right. Thanks.
Classic. All good. Cool beans. So another big project that I've been working on has been, I think if you guys mute yourselves, it'll revert back to me on the big screen. Maybe. Okay, I don't know. Maybe it's just me Okay. Don't worry. Yeah, so anyway, another project that I have been working on recently has been making prosthetic fingers with the Toowoomba hand therapy group. And something like this anyway, I think is like a super exciting concept because like while this design is open source, we just downloaded it and put it together off thingiverse.com. You need a couple of bits of elastic, 2 little pins along the movement axes to put this thing together. And like when it's like on a patient's stump, the idea is that this stick attaches to a wristband so that when you move your wrist back and forth, it goes to grab. So we got to give this to a patient at the end of last year, and he was absolutely ecstatic to get something like this because he was saying that like after recently losing his finger, he was getting quotes from some high-end prosthetic companies to get these made, and he was looking at around $50,000 to get this made up, and this probably cost me under $10 to make at home. So I feel like in terms of small business in this particular area, I think there is a huge niche area there for making custom budget prosthetics for people with disabilities or assistive technology type stuff. So I feel like it's a really promising area for businesses to start looking into. And I've been trying to desperately get this idea out there to people. Someone please take it. Go and do it. But the latest iteration of this project, and I fortunately don't have a sample here because I ended up giving them away yesterday, was I made a custom one of these again using a 3D scan of the patient's stump. So it's a custom socket now that fits directly on there, and hopefully I'll get some feedback in the next couple of days to see whether it was a good fit, whether it needs tweaking, all those kinds of details. So I'm really looking forward to seeing how that turns out. I've got some other example projects here as well. What else have we got? So I'm really into my flexible materials, exotic materials, and like the idea of wearable technology as well. So this one here is one of my favorites. It's a 3D printed jacket, and you can sort of see how bouncy it is anyway. I've also got stuff like 3D printed chainmail as well. This is really satisfying to hold. This all prints in one piece, no assembly required. So you can do like print in place hinges and things that move, which is pretty cool. Sort of a step up again from 3D printing fabric is 3D printing directly onto fabric as well. So you can print stuff like this by starting the print. See how it sort of started on the bottom there. Getting about 3 layers up and then putting a layer of crystal organza fabric down and continuing to print so it builds up and sandwiches that fabric in the middle. And I feel like there's a lot of, really creative ways that you could use this technique to do some pretty wild stuff. So I've also got here a 3D printed bracelet that was printed flat on fabric and then cut out and glued together to make something like this that has little fabric windows in it, which is pretty cool. So lots of different ways you can go and be creative with this kind of thing. Lisa says, how do you go with medical approval? I know Envision Hands had issues due to pressure sores, etc. with patient limbs. Excellent question. So this particular project is not medically approved. I've just made this up. No one's approved it and said, oh yeah, that's good. So don't make this for yourself and be like, Dr. Steph said it was okay. She prescribed it to me in this workshop. Don't do that, please. It's just a concept idea. But talking about medical approvals, another big project I've been working on has been making these 3D printed face shields for the local community as well. So most of you probably heard about this already, but the idea behind these is that you've got a 3D printed band at the top here, band on the bottom, and it's a full-on face shield style protection for frontline healthcare workers to protect them from patients coughing and sneezing and all that kind of stuff, so that it won't get in any of your eyes and your nose or any of that sort of area. And so I've been working with a whole bunch of local businesses to make these, and so far we've delivered 370 to the local community as a donation, which is pretty great. But in terms of the question around medical approval for something like this, generally for this type of thing, you have your big sort of regulatory body in Australia called the TGA, or the Therapeutic Goods Administration. And TGA have released a legal exemption article for PPE like this that has been created during the pandemic area, like the time. And there has been a few companies as well, local to Brisbane, that have gone and made their own version of the face shield and gotten it TGA approved. And so one of those is the 3D1 headband here. So you can sort of see, I suppose, the difference between these two designs. You've got this one here is a bit skinnier. It's faster to print, but it is a lot more flimsy, and you do need to wear like a pair of glasses or something underneath for it to not slide down your face. Whereas something like this is the standard one that's been used around the globe. It's not TGA approved, but it is a more sturdy design that will sort of is a bit more comfortable and easy to wear. So there you go. Another question, can fabric be washed okay? Yeah, it should be. I haven't actually tried to wash it, but I think some kind of a slow wash, because it would be quite heavy for something like this. Yeah, I think it would be possible if you were making some kind of an elaborate costume to turn yourself into a fish person or something. I know that's exactly what you guys were thinking about. So there you go. What else have we got here? I've also got a 3D printed shoe. This one's pretty fun. I'm really keen to eventually, like for my 3D printing workshops, have a fully 3D printed outfit that I can wear in to the workshop. It's my life goal. So one day you'll see me rocking these bad boys down the street, going to my 3D printing workshop. It's going to be a good time. I've also been pretty busy working on the idea of doing 3D printable furniture as well. And I'll just do some screen sharing here because I didn't end up bringing it down with me today. Let's jump on here. Okay, share. Cool, so this is my blogging website. And here we go. So this is a 3D printed stool that I've been working on. And the idea is that like you can put this together using timber dowel. And so here's a little example on the video as well. This one's just a stool sample. Terrible joke. Anyway, so I think what's cool about this type of concept anyway is that it sort of really illustrates the idea of a decentralized economy type business. So for example, if you were to 10 years down the track, go down to IKEA, they might not have any stock. You know, they might just have a bunch of big 3D printers out, and you go up there to the screen and you go, I want this stool. And then it goes and 3D prints all of the connector parts automatically for you. And then you go and you collect all those parts and you grab all the dowel and you take it home and you assemble it yourself. And then in a decade's time, and you're really sick of the stool, you take it back to IKEA, you put it in the big shredder, and it shreds it up and turns it into something new for someone else. So thinking about it that way anyway is your decentralized economy where everything is made locally. There's nothing shipped from place to place using, excess shipping costs and all of the environmental impact of shipping things around all the time. Everything's made at high quality and hopefully it's recyclable as well. So I think there's a lot of benefits anyway to sort of thinking about making things locally and the potential to, respond locally. And that sort of is really shown as well through the face shield project. So, while mass manufacturers are gearing up to make these face shields and injection mold them, our local manufacturers here in Toowoomba, our local businesses have been able to, work really fast and be an agile solution to respond to that need locally. We don't necessarily need to order things in from China anymore. We can make it ourselves with 3D printing, which is pretty exciting. So that's what I really like about those projects anyway. Cool. I think that's about it for the projects that I wanted to show off today. I will switch back to the presentation. Can you guys see the presentation? Do I need to reshare? Yes, you can. Cool. Okay. Let's get into it. Whoop. Sorry, guys. Jumping back a bit here. Okay, so when you want to get started with 3D printing, the first thing you need is a really cool 3D model to start printing out. And so the best place to start looking is the classic thingiverse.com. So we'll have a quick look at thingiverse.com on their website. So this is the largest repository of free 3D printable models on the whole internet. And while I don't particularly like the way that they've rebranded and done their website, it is the best place to find cool things to print. So, for example, let's jump in here with the old Star Wars. So you can start to see all the things that are available for you to get in and start printing. These files are all free. People have just made them and put them up here. and they're ready to go to start printing out. Usually when you pick something that you like and you want to print it out, you get into the file here and you're like, oh yes, this is perfect. This is exactly what I need, you know? And then you go down and you jump into the thing files here. And usually it'll have an STL type file down the bottom here attached. So your STL file is your stereolithography type file, and it is what you're looking for to 3D print. It's a 3D model type file, or it's, I suppose, some people call it the pattern as well that they use to print with. But yeah, it's a 3D model. You can also use .obj type files as well, and there's a new emergence of .3mf type files, but STL tends to be the industry standard at the moment that you're looking for. Yeah, so let's have a look and see if we can have a look at some other models on here. So another one of my favorite parts about Thingiverse is the ability to customize models. So one of my favorite models on here is the magnetic hinge box. So this is an ability that Thingiverse has that most people tend to not realize that you can actually do, and it can save you quite a lot of time when you're trying to make something specific. So generally, if you want to make a box, to put something in, to protect something, to give as a gift to someone, you know, you want a specific size. You don't want to just make any old box. You want to make sure that it is going to be the perfect size for what you're trying to put into it. And so this magnetic hinge box model anyway is a customizable model, which means that you can open it up and customize it, like I'm trying to do here with the internet, and yeah, you can make it the perfect size for your needs. How exciting. So you can jump in here and you can fiddle with all the sliders here, and you can output something that is perfect for your needs.
So if we just ask a question about that,
yeah.
So that is, you don't actually go and use your software. It just creates it on the fly in your STL format.
Yeah.
Based on whatever the sizes are.
Hell yeah.
So that,
yeah.
Never knew that existed.
Yeah, yeah, it saves you a lot of time. Yeah. And there's like, not every file on there is going to be customizable. To make customizable models, you need to make them in a program called OpenSCAD or OpenSCAD. And it's a little bit trickier. It's sort of writing, it's like 3D modeling with code. Yeah, so some of the other great customizable models that I've come across is like this chainmail that I was showing you before. That is a customizable model. So you can generate any size sheet, any size link of chain that comes together to make these. There's also customizable hinge models, wheel models for making robots, all kinds of great stuff on here. And so if you want to find those customizable models, you've got to type in the word customizable with a Z with your keyword to try and find those. Or you can also use the keyword parametric as well. That's a great keyword to use. Yeah, so that is a bit of a taster of Thingiverse.com. Real quick, we'll jump into My Mini Factory as well and have a quick peek at that one. So in my opinion, My Mini Factory is the next best thing when you're looking for 3D models to print. And where it really shines is its ability to make high quality content. So it's more of a quality over quantity type website to go and look at. Everything on here is guaranteed 3D printable, and I have quite a lot of stuff for desktop gaming. So if you are playing Dungeons and Dragons or any RPG tabletop type games, and you want to have little monsters that are like, Golem on R3, what are you going to do? You know, that kind of stuff. So lots of stuff that is really well made for 3D printing on resin style machines that could really achieve that extra high detail. Let's have a quick peek though. So under props and cosplay, you can start to see the type of quality that you can expect from My Mini Factory. So you've got fully 3D printable Stormtrooper helmets, like big props, all this kind of stuff is usually printed in like a whole bunch of different parts that you then sand, paint, and assemble as a project. Usually, you know, for cosplaying. Lots and lots and lots of stuff on this website. It's an absolute rabbit hole. So if you want to just block out the rest of your afternoons in your calendar to just look at this website, that's a convenient tip. There's also a store on here as well, so you can buy high quality models that people have made. All kinds of stuff on here. Also have a quick look at home and garden as well. And you can also get this really nice stool model on here as well. Wow. Wow. Yeah, so you can make it yourself. Have your own little home IKEA. Cool. They also got competitions on this website too, so you can jump on here, and if you want to practice your 3D modeling skills, you can pick out one of these competitions and enter into it. So I used to do this for a fair while back when I was still learning, and I managed to pick up a few prizes along the way, which was pretty great. But yeah, My Mini Factory, there you go. There's the hot goss on that one. Okay, so if you can't find the part that you're looking for on any of these websites, the next best option for you is to have a go at modeling it yourself. So the scenario is potentially you're at home and a little bit of the end of your vacuum cleaner snaps off and it is now rendered unfunctional. What will you do? What a disaster. So you've already gone onto Thingiverse and you've typed in Dyson and you've had a quick peek on there and you're like, oh no, they don't have the right Dyson part that I'm looking for. They have everything else under the sun, but no one's made this particular model of part for it. But it looks like a simple part. Maybe I could have a go at 3D modeling it. What you want to do is jump onto a website called tinkercad.com. And so if you aren't especially tech savvy, fear not, this website is designed for children. So it's a really intuitive, easy to use interface to help you get started with 3D modeling. And usually if you want to reverse engineer something as a bit of a life hack for at home or work, what you do is you bust out your ruler or your pair of calipers and you get your object and you start measuring it up, doing a little sketch to get you started with actually 3D modeling it up yourself. So what we'll do on here anyway is we'll jump in and we'll create new design. You can sort of notice on here that it's a browser-based 3D modeling application, which means that you don't have to download any software and anything that you've made stays up in the cloud, which is super convenient, especially if you potentially have a work laptop at home, working from home, or your computer is absolutely terrible and can't handle any type of big, heavy software and all the heavy lifting around that. So yeah, it's a great, easy to use, easy to set up application. All you need to do is sign in and make an account and you can get started. Tinkercad also has like a whole bunch of awesome circuit building interfaces as well, where you can import like an Arduino board and like some LEDs, and you can do block-based coding to drag it in there. And yeah, it's pretty nice. Loading for days. Okay. While this is loading up, I might maybe jump ahead a few steps. We'll give it a bit of time and I'll talk a bit about 3D scanning for a bit. So the next option anyway, if you can't quite find or make that 3D model that you're trying to do, a good option is to try and 3D scan that model. And I see that Kieran's just jumped into the video as well. So we're doing a bit of a 3D scanning project together at the moment. Did you want to, are we allowed to talk about it, Kieran? You'll allow it?
I'll allow it. This has been so fun, Steph. Thank you.
Yeah, don't worry.
Do you want me to 2 minutes on what I'm doing? Or a minute?
Yeah. Give us the deets.
Okay, so a little while ago, about a year ago, my grandmother moved into a home situation, like care, and she gave me a lot of things. And when I went through them, there was some beautiful work that she'd done, but it was about, I'm guessing it's getting to be like 50 years old now. Is that right? Yes. So 1970s. And I just wanted to see if I could preserve it. So I went along to a meetup that Steph was running at USQ with Joy one afternoon, and sort of talked about it. And Steph thought it would be possible to 3D scan them just to preserve them as a digital file. And then, so my grandmother was a dressmaker and a milliner. So a lot of her things were like bridal parties. So bride and her bridesmaids. So there's some things there that, things that we wouldn't wear now, sure, but I've picked out a couple of things that I could definitely wear myself, and yeah, we're just trying to see if we can preserve them.
Yeah, cool. So with that project, I took them into work yesterday and I have now 3D scanned them. So we had 3 objects we're trying to 3D scan. We've got like a thin band that fits over the head, a thicker band, and then a big hat. So the 2 bands turned out pretty nice, but the hat was like not as good.
It's tough because they're a bit old now too.
Yeah. So when we're 3D scanning and doing projects like these, there are a couple of different options that we can choose from. So The one that we have in the makerspace at work is a turntable style 3D printer, and it has a bed size of 200 mil cubed. So that means that we can scan anything that's smaller than that size to a degree of pretty high detail. So it's great for, you know, preserving stuff like that. I've also, honestly, don't tell anyone, been hoarding dinosaur toys to scan and to upload to Thingiverse. All that kind of good stuff. So yeah, it's been super fun to have this thing. And when you upload those models anyway, you see people using them for pretty unique and wild applications. Like I've seen people, you know, remix some of the animal models that I've uploaded into little monsters for their tabletop games, little ornaments, all kinds of weird and wonderful things. Your other option for 3D scanning is your handheld type scanner. And I have a little handheld type scanner that I usually do a little demo of in the workshop. Obviously I can't scan anyone now unless I pop next door and scan Joy. But usually it looks like this. So it looks like a little Xbox Kinect type thing. It's got a couple of cameras there to give you a bifocal view. And then it's got a second, third camera there to give you a little laser distance sensor. And so with this, I can actually walk around a person while it's plugged into my laptop and scan someone's head. And so this is an example of me scanned with this scanner. So you can sort of see the detail there. You know, it's all right. You can tell that it's me. Usually these things are a bit of a one-trick pony though. This one cost me $200 plus an extra $200 to buy the software to help process all of this. So $400 deal, and it's a bit of a one-trick pony, to be honest, because you can only really scan heads. Anything that's bigger or smaller than that is a colossal pain in the ass, and it's not very good. So don't get one of these thinking you can go and scan your car or something like that and be like, yeah, I've a miniature version of my car. No.
So, Steph, mobile phones, can they be adapted, especially ones that have depth sensors, to facilitate this same thing without having to buy the hardware?
Yeah, for sure. I think there's probably some, like I haven't had a good deep dive recently, but I've always seen apps that can do 3D scanning type tech, and they're about the same quality as something like this, I think. So instead of directly doing a walk around, you end up taking around 50 to 80 photographs of the object at sort of staged angles and intervals, and then it stitches it all together into a 3D model.
So it couldn't be equivalent of, say, video, where you have video running with walk around?
Yeah, same sort of thing. Yeah, there's got to be something out there now. Like there used to be 123D Catch, but that's now been taken off the App Store. But yeah, honestly, with the way that, you know, phones are going, there's got to be something good out there now.
Well, they're coming with, some of the top end ones come with laser depth measurers, or whatever it's called. Yeah.
Now I'll definitely have to go into a bit more of a deep dive, I think, around smartphone scanning.
Thank you.
When I ended up putting a picture of myself like this on Twitter, I was like, I'm beside myself. A friend of mine commented back, and she's like, what are you doing with that trash 3D scanner? Come and get scanned with my industry professional 3D scanner. And I said, okay, Christy from Ditto Labs. And so this is me scanned with a $25,000 scanner. How terrifying is that? It's too much detail. So, like, I honestly sometimes prefer potato Steph than HD Steph. But yeah, there you go. So that's generally what's possible. And this one was scanned with a handheld 3D scanner as well. And from what I've seen, there isn't like a nice sort of like price incline with 3D scanners. It's usually like $200 or $10,000, which is a bit of a shame. So if you do want to get 3D scanning done for a project that you're doing, I'd recommend going and having a chat to some of the professionals out there. Or alternatively, like honestly, you tend to get a more clean and better functioning model if you just CAD model it up yourself. Especially if it's just got some nice clean lines. It's not anything weird or curvy. It's just a bracket of something. Just have a crack at CAD modeling it. It's much easier.
Well, what about colours? Like I noticed that wasn't really a good representation of your complexion, those models.
That was me with a fake tan.
Can 3D printers either print in many different colours, or can they? Is it printers that can apply colour, like you can print on a piece of paper colour? Can you print on a three-dimensional surface that you've just printed, or simultaneously?
That's a great question. So down at USQ, we've got a business that sits on the side called Ellipsis Media. And they've got a HB 660 ColorJet Pro type thing that can print in full color using a powder-based type technique where it puts down a layer of powder and it puts in little inks in there as well, and then glues all these powder layers together. And they use those for like when you graduate at the uni, you can choose to get 3D scanned along with your graduation photo, and you can get a 3D model of yourself in full color with your graduation gown, which is pretty cool.
The actual substrate is coloured. It's not printed on the surface. It's actually printed in the structure of the model. So it's a very different technology to this 3D printing technology.
Yeah. Just saw a comment there from Irene. Maybe Donald Trump is that colour because he scanned himself. Yes, that's exactly.
So the question was, it's a very different technology to what you're familiar you use.
Yeah, that's right. So, in my opinion, those machines, like you're looking at around $80,000 to get one of those, right. And the models that come out of them look stunning, but they're not functional. So they're not going to have any kind of strength to them because it's just powder. It's just, you know, right. Any weight that goes on it is not going to go well, and off it goes. Yeah, so the other option as well for colouring your parts, I wouldn't sort of recommend it for something like this because it'd be a bit tricky, is doing a hydro dipping method. So I don't know if you guys have seen hydro dipping videos on YouTube where it's a technique used to put graphics on models that aren't printable on. So like helmets, the rims of your tyres, and what they do is they put a graphic on the surface of water, and then they can get their part and they can dip it in, and it gets coated in there with that. So you could, if you were really clever, do some kind of a texture map and like do that with yourself, but I can see that going wrong very quickly. Might be a few practice tries needed. It is very possible to put your own custom graphics on models made with a standard 3D printer like these ones here. Cool, cool. Okay, so we're not having too much luck with Tinkercad, but we will skip ahead and continue on. Okay. Well, once you've found an awesome 3D model, your next step is to have a go at slicing that model. And I will just fire up some slicing software so we can have a bit of a look at that now. But yeah, essentially your slicing software is just firing up the software. It's just thinking about it.
Are you supposed to be sharing screen?
Not yet. It's not ready yet.
Okay.
Hurry up, software. Yeah, so your slicing software is like the step before it gets transferred over to the printer. So what it does is it takes your 3D model file and it slices it. That's why it's called a slicer. Chops it up into its layers. So generally how 3D printing is done is it puts down all these little tiny layers to build up into your final product. So it's turning that model into commands that the machine can understand pretty much. And it's turning it into what's called G-code, which is pretty standard among like CNC type machines, like usually for doing woodworking. That's where it sort of came from. It also defines as well how strong that model is going to be, how high detail you want it to print out, what kind of infill you want on the inside, all of those key details that will you know, make your model look fantastic as the end product. Okay, let's see if this software is going to boot. Yep, it's doing it very slowly. That's right. Okay, we're in. It's happening. Let's do some screen sharing. Okay, let's go. Can you guys see that okay? Excellent. Cool, cool. So the first thing we'll do is we'll jump in here and we'll grab a random 3D model that I have downloaded in the past. And okay, let's just grab this one. Anatomical heart model. Cool, cool. So in this software anyway, you've got a representation of the bed with this grid. So when you're importing your models, you can usually get a bit of an idea of how big that model's coming out by just eyeballing it and going, oh yeah, I sort of want it to be about that big on the bed. But you can also go and choose exactly the right size it needs to be. So in here you can say, oh, I want this to be 120% bigger, or I want it to be exactly, say, 100 mil high. So you can go in there and choose all of those things. You don't have to do that in the 3D modeling software. You can also try and print out multiple of the same object at the same time, or you can set up a whole bed of different prints if you want to as well. So you can set all that up in here. which is pretty cool. You can also go and move the model around. You could rotate it, all those kinds of standard things. Let's have a look at some of the settings over here if we can. Okay. So over here, these are your sort of standard settings that you'll tend to be fiddling with in your 3D print. You've got your layer height, your infill, and your support. So your layer height defines how high resolution the model will come out to be. So the thinner your layers, the more detail will come out in that print. The thicker the layers, the more potato it's going to look, but the faster it's going to come out in the print. So for something like this, choosing a layer height of 0.1 at this end of the scale is going to look absolutely fantastic, but it's going to take ages, but it'll be totally worth it because it'll look really high detail. Whereas if you're just printing something that looks like a space croc like this, you don't need to do really, thin details. You could crank this up to 0.3 mil layer height maximum, usually I do, and that would come out really fast then if it was just a prototype. You can also choose your infill here as well. So we will go ahead and slice this model so we can see what our infill looks like. So the infill is a grid pattern that happens on the inside of the print and usually defines how strong it's going to turn out to be. So it's a percentage of 100 where 0 is completely hollow and 100 is completely full. And so if we jump into our preview area here, we can hopefully get a peek at some infill in here. Maybe, maybe not. Okay, this model is too thin for infill. Great example, Steph. Let's have a little peeky at this though. So you can sort of see, like it's pretty nice how you can sort of get an idea of where everything's going to go in this model using this G-code simulation. Yeah, so for this type of model, I can sort of already tell that it's not going to stick down to the bed very well. If you've got a really small connection point, usually the print will flake off, which isn't very good. So I would usually go and add support structures onto this one. So if we reslice this model, we can see what support structures look like. So supports are like little towers that automatically generate to hold up that print in place. And looks like it's put supports on the inside as well, which we may or may not want. So let's have a look at this now. So we can see those support structures on the outside of the print there, and usually those would be sacrificial. So you'd trim them off afterwards, but it would mean that you would get a successful print at the end of the day for something that has overhangs. Cool, cool. I might just try to import a different model so we can see what the infill looks like real quick. Okay, what else we got here? Octopus, that's a good one.
Steph, just on infill, if you had you can select to have no structure, can you, on a model, or does it automatically by default decide support structure?
Usually you choose that yourself. So you can choose
no support structure, could it completely fail?
Yes, that's definitely, there's a bit of trial and error generally involved with 3D printing. It isn't just, plug and play, oh, it's going to work every time.
So there's not an advisable button which says, here's what we recommend minimum.
Yeah. You can usually sort of eyeball it and tell with a bit of experience. So if something looks like it's not going to have any layers underneath it to hold it up, usually that's when you know you need some supports.
So it's not a fail-safe as such to say where you can have a model. Like if you didn't have any of that support structure in the middle there, there's not a default buttons advisory saying, if you don't have the support structure here, we predict this won't work.
No.
Right, okay.
It's not as foolproof as we would like.
Yeah.
I sort of like that though. Like I like the freedom of being able to choose to stuff it up myself if I want to.
Yeah, freedom to fail, yeah.
Yeah, that's what it's all about. But yeah, you can see the infill here in the middle now. So we can see that this octopus print at 10% infill is going to take 2 hours and 9 minutes. But just say we want the strongest octopus known to man. We want 100% infill. Let's slice this up and see how long it's going to take instead. Dun, dun, dun. Okay, so now it's going to take 3 hours. So if you are on a bit of a time limit, you can generally play around with that, with all those things and sort of, get something that is, around the sort of time that you're happy to spend 3D printing that particular object. Cool. Okay, can you guys see the presentation again? No, I need to reshare it. Yes. No. No. Okay, I will quickly reshare the presentation again. Okay. So let's jump into a quick chat about material choice, if we can. Okay, so usually like anything that's 3D printed is always going to be made out of plastic. So plastic has the right thermodynamic properties for it to be heated and cooled and solidify rapidly. So usually anything you're 3D printing with a standard FDM style machine, not a paste extruder, food type machine, is always going to be plastic. Let's see if we can jump into this. Okay, here we go. So your two main types of plastics on the market right now are your PLA, polylactic acid, and your ABS, something butylstyrene. And so PLA, if you want to get a machine, is your best starting option off the bat. It prints like a dream, works really well, and yeah, it's really user-friendly, easy printer material to start with. Its only weakness is its glass transition temperature of 60 degrees. So if you're going to make anything that is going to be sitting outside or sitting in your car or something like that, it's not going to be too good. It's going to start to melt and warp out of shape very quickly, and it tends to degrade quite quickly in the sun because it is a biodegradable material. So it's the same stuff that your bio cups and bio plates and stuff are generally made out of, that type of biodegradable plastic. It's meant to be able to completely biodegrade within 90 days in the presence of a bacterial agent. But yeah, your next one there is your ABS, which is a lot stronger. It's what Lego's made out of. It's a bit tricky to print with though. It is you really need an enclosed machine to make sure it has a stable heat temperature environment on the inside. So it is a bit more of a more expert material to use. So it does take a little while to actually get up and running properly and calibrate your machine to work with ABS. But of course, the benefits of using ABS is that it's a lot stronger, it's a lot more heat resistant, but it can also make a bit of a smell as well while it's printing. So you're better off trying to print it in somewhere like your garage or somewhere that's well ventilated and not being sitting around a machine that's printing ABS all day, because I've done that before and it does sort of make me start to feel a bit sick. Not too good.
Steph, do you guys have an ABS machine at USQ?
Engineering does, but in the makerspace we just print PLA.
Okay.
Yeah, there's some new types of filaments as well that are coming out, like PETG and ASA. That's like PETG especially. It's meant to be able to have the strength of ABS, but the ease of printability of PLA. So there are some great new players in the scene anyway in terms of material choices. Cost-wise as well, you're looking at an average of around $25 a kilo to pick up some rolls of filament, which is pretty decent. So it is very cost-effective. Something like this, is going to cost you $2.50 to print. So it's nice and cheap. Means it's easy for you to go and make a whole bunch of different iterations and to actually do your prototyping process with 3D printing, which is pretty great. As you sort of run your eye down that list though, you've got some companies that are in the Steph sin bin, shunned. So they're just trying to rip you off. So the Up brand machines, the MakerBot brand machines, the Da Vinci brand machines, they are trying to get you onto the classic paper printer business model where you pay more for ink. So you can see here on this price list, they're trying to slog you between 90 and 120 bucks for not even a kilo roll, a 900 gram roll of the same stuff. So if you're chatting to a salesperson, they're like, oh yes, you need to pay extra for the quality. You do not. Tell them to get in the bin. It's not what it's about. Yeah.
Yeah, Steph, a question I had, there's raw plastics. Is there metals that can be printed, or is it an expensive process to melt metal and print it?
I'm so glad you asked. Here's some exotic filaments.
Oh, yeah, okay.
Excellent question. Yeah, so you can sort of print with metal, bronze fill. I've had a bit of a crack at before, and it's essentially printing real bronze particles inside a matrix of plastic, and you can polish it up to make it look like a metal finish, but it doesn't have the strength of metal, just the look of metal. You've also got other stuff on here. So all this flexi stuff that I've been showing off today, I've also forgotten to show off my 3D printed wallet as well. This type of stuff is all made out of TPU, which is your flexible type filament. You do usually need a special machine to run TPU though, because it is a bit more flexy, and it needs a special extruder design to actually push it through without it wobbling out. But yeah, one of my favorite websites to jump on to go and grab some exotic filaments to try out instead of buying a whole roll is Global FSD, globalfilamentsampledepot.com. So you can buy a 10-meter roll for like $5 or something. It's very addictive. I try not to go on there, lest I spend all my money. But yeah, it's a good time, that website. I know that time's moving on, so
I'm just going to jump in super fast and just say, here at Canvas Coworking, we recently picked up some funding. We've got another 3D printer on the way, one of those ones, and $650 worth of different filaments sitting there waiting for me to unpack, including a whole lot of flex filaments, the nice shiny silk ones, the ones that look like metal. Yeah, they're all there in addition to our whole suite of colours. We've also got some transparent ones and some that look like wood, gold, silver and bronze.
Hell yeah, and if people want to come down to Canvas and do some printing, they can.
They can.
Cool. So rather than buy your own machine, jump down to Canvas, have a bit of a go. If you want to do some 3D scanning as well, I forgot to mention, you can just pop into USQ when it's open and you can do 3D scanning for free down there with our turntable machine. But let's jump into what machine recommendations I have. So there are too many machines on the market right now. I can't keep up with them all, even though I would like to try them all out and have fun with all of them. But these are the ones that I have used and highly recommend as a potential printer for you to buy. So in the budget range, anything from Creality is a goer. So Creality is your cheap Chinesium type machines. And these are like, honestly, the absolute best. Like the bang for your buck is phenomenal. So the CR10 machine, you've got a bed size of 300 by 300 by 400, huge. And it is gonna set you back about between 500 to 700 bucks, which is like super decent. These things as well.
$865.
$865 from Australia. If you want to get from like Banggood or Gearbest or somewhere like that, you can cut yourself a deal if you game. Yeah, so the machines I've got at USQ are all CR10s, and honestly, the amount of battering around they get by the students every day, and they still work, is amazing. So they're a great machine to start with. And what I really like about these machines is that they're so cheap to maintain. So there's a few parts that will tend to wear and tear over time, including your nozzles, your PTFE tube fittings, all that kind of stuff. And they are so cheap and easy to replace yourself. Usually, like I'm used to working with these up-brand machines that I absolutely despise. And generally, like if something goes wrong with it, you can't just buy, a new nozzle or a new little bit for it. You have to buy the whole $400 extruder assembly to replace it, which is like, why not just buy a whole new machine for that cost, And yeah, this week the CR10s at work have started to it's not holding its temperature, and so it's time to buy a whole new extruder assembly for it, and it's 35 bucks. So I'm very happy with these machines. The next budget one there is your Ender 3. That's looking at around 300, 400, 500 type bucks. It's got a smaller bed size of around 200 by 200 by 300-ish. And yeah, it's another fantastic workhorse, just same thing, small size pretty much. If you've got some more money to spend, here's my expensive printer recommendations. So I've personally got 2 Lulzbot Taz's at home, and I was able to pick them up on Facebook sales for about 1/3 of their price, and I fixed them up. And they're an absolute dream for printing with exotic materials like your flexibles. So I really adore them for that particular feature, but they're a bit more fiddly and a bit more mucking around sometimes to get them fixed up. It is an open source machine as well though, so you can print out spare parts for days for it if you want to, build your own. But the Lulzbot company anyway is starting to go under, which is a bit of a shame. So I've seen that they've started to lay off their staff, so that's something to keep an eye on anyway if you do want to get one of those machines, but I've had a pretty good experience with them so far. The next one there is your Prusa i3. I really love that machine. It's one that's shipped in a kit and you put it together, and it is the quietest machine I've ever heard in my life. Like, it is deadly silent. I was like, wow, is that machine even running? Like, yeah, it's beautiful, this thing. And it's by Joseph Prusa. He is the father of like open source 3D printing movement, and yeah, beautiful machines. And you can also get an upgrade for it that lets you print in many different colors at once. I think 5 or 6 different colors, which is pretty cool. Anyway, time's getting on. I will open the floor for questions, general discussion. Hope that wasn't too
Got a
fast.
question?
Sorry, no, I was like, ah.
I want something to eat.
Sorry. It's never a question. Can I print some food? No.
Well, yes. We've got a food 3D printer, USQ. Pretty cool.
Steph, a couple of questions that come in a session I was on earlier today for people who couldn't be here was just regarding, you know, if you have a business and you hadn't really considered how 3D printing might be something that you could use before. I know you mentioned a couple of things at the beginning, but maybe if you can just remind people, you know, what might they be able to do with 3D printing for different types of businesses?
Yeah, for sure. So depending on what business you have, like 3D printing generally is useful to have in terms of making your own replacement parts for things. So if you have lots of different types of machines that, you know, need to be upkept and maintained, and you need to have it going fast now, it's pretty great for that kind of thing. It's also good if you're making your own like custom gear as well and you're doing your own prototyping. Obviously, like the technology is called rapid prototyping, so it enables you to make something unique, fast, iterate fast, you know, get through all the different testing you need to do without going ahead and getting a mold cut for injection molding before mass producing that particular item. It's also good for making enclosures if you know, are making, you know, things that need to be in a box, whether that is like a gift type thing or whether that's like an electronics type, put it in an enclosure type deal. Obviously, I'm a huge fan as well of all the prosthetics type business potential. But yeah, so like I think anyway, 3D printing is a good option to consider, you know, whether you potentially, you know, you might not be looking at getting a machine, but you might instead just need a couple of things and you might just come into Canvas Coworking and make that yourself.
Cool, thank you. I think Irene had a question there.
Sorry.
Irene, do you just want to ask your question?
Yeah, I just wanted to ask if you did the last slide there on printing and finishing.
Oh yeah, we can do that. We'll let Paul jump in with a question first.
Yeah, I did touch on metals before. I noticed the metals you talked about all were based on a 3D substrate. Is there actually, it'd be more of an industrial circumstance, but is there someone somehow actually printing like steel?
Yes, there is. So the biggest player in Australia that I've seen is a startup company down in South Australia called Titomic, and they've done some pretty awesome seed rounds recently, I think. So they're like the biggest player in terms of doing that. More locally though, you've got reps for the company Mark Forged locally, and they are starting to get into the area of metal 3D printing. Same sort of style where you've got a matrix of metal particles inside wax, and it prints it out 20% larger than it should be. And then it goes into a sintering machine for a bit, and it melts out that wax and shrinks it down and like, you know, heat anneals the whole thing together into a metal 3D printed part. And while the material for doing that is pretty cheap, the actual sintering machine pretty much is a big kiln. And it's about, the rep told me last time, it was usually about $500 per session to actually just turn it on for the electricity cost, which is pretty wild.
Because I can imagine, in the ultimate to have in a home, if you needed to print something you want to do it cheaply, economically, and have the absolute strongest material that's available, which is, I don't know, as steel or titanium, whatever it may be. But there's usually fairly expensive trade-offs, melting it. It's just a simple process of forging through a printer. But I just can't imagine.
For the sake of time, we might just jump to the remaining slides, and then maybe you can chat about that later. And there's a new company in town as well that's got one of those that's looking for customers. So if you want to get that done,
okay, yep.
Have a chat to the guys from Decisive.
Yep. All right, thank you.
Yep.
Yeah, okay, so let's jump into printing and finishing real quick. Okay, so I've already talked a bit about hydro dipping. Usually in these workshops, I'll do a live hydro dipping demo. It's a bit hard today. But usually, like the standard way to finish your models, if you were a cosplayer or a prop maker, is by doing a process of priming and sanding, where you go down to Super Cheap Auto and you pick up a can of primer filler, which is usually used for like buffing out dents in cars, and you spray it on. So this one's been sanded and primed as well. So do a close look at this one. So yeah, you pretty much spray it on, you sand and you spray and you sand, and you work through your different grades of sandpaper until you end up with a finish that when you paint it, you won't be able to tell that it's been 3D printed. So this, like doing it this way is like so time consuming. So don't like take this on lightly. It is a project in and of itself. So if you're a keen cosplayer, you want to make your own costume type stuff, yeah, doing this, you know, give yourself a solid year before your next convention. You know, don't do it in a month or something, unless you've got some nice Santa gear or something. Yeah, so that's one of the options that you've got. What else have we got here? You can also, you know, do stuff like potentially painting it over with like a resin finish. ABS as well can endure acetone smoothing or acetone finishing. So I'll just dig out my sample for that one. But essentially what you do is you can like expose ABS to acetone vapor and it smooths it over. So I don't know how well you guys can see that, but it's a lot shinier, has a bit more of a sealed injection molded look finish, which is pretty nice. Usually the way I like to do this is by mixing up acetone and ABS in a little container and doing a dip type method. But if you're looking at acetone smoothing on YouTube, you've got all kinds of dodgy players out there putting acetone on your stovetop or in your slow cooker or insert cooking appliance here. Don't do that. It's like, it's a danger zone. Acetone is highly flammable. So you need to be very careful if you're doing something like that. And even when you're just making up a slurry and not having it near any heat or flames, you've still got to, if you want to keep that chemical mixture, you've got to treat it like a chemical and label it properly because you've pretty much just made a sticky flammable. Yeah, so that's a bit about your acetone smoothing. Yeah, otherwise, if you just want to paint it, a bit of acrylic paint, you know, is nice. And you can just, like, if you like really want to do like miniatures painting, you can buy like special miniature paint sets, which will work a treat as well. And as long as you know, get some kind of a clear spray finish to seal it off at the end, that'll turn out pretty fantastic. We also have a question here.
Had someone print some little tanks, and he's here today actually, and printed them just in a white, you know, white filament, and then he painted them like, you know, camouflage. They come out really well.
Yeah, hell yeah, cool. It is past 1 o'clock now. Thanks so much for coming along, team. I see there's a couple more questions here. I'll keep answering them, but if you guys need to be somewhere, feel free to jump off. Thanks so much for coming along.
Thank you, Steph, for that presentation. I'll stop recording shortly, and if there's any other extra questions, hang around to ask them, those who can stay. Thank you for attending, everyone.
Thanks, Hugh. Thanks, Steph.